Good day, everyone. Welcome to our physics review session. So we have here a question on speed time graph. So actually this is speed and time graph, and it could also be called as an acceleration graph because the slope here refers to acceleration. So let's read the question. So we have here a graph showing how the speed of a car changes with time after the driver sees a dog on the road ahead and applies his brake. So of course the driver was moving at this speed here. He's moving at constant speed, and then when he saw the dog, he pressed the brake and the car decreases its speed until it stopped at C. So let's deal with the first question. State the point on the graph at which the driver applies the brake. So as what I told you a while ago, it presses the brake at B. So the answer here would be simply as B. So how long after seeing the dog did it take for the driver to apply the brakes? So think the driver sees the dog at B. So what you're going to do is you're going to get a ruler and then draw a line going down because your time is on the x-axis. So you draw a line down, and then you will be able to measure. So let's zoom this so that you would be able to see it clearly. This is 1, 2, 4, 6, 8, and 1. So this is 0.2, 0.4, 0.6. This is 0.7. So it takes 0.7 seconds for the driver to press the brake. So it's 0.7 seconds. Or shall we say second? Now calculate the distance traveled during this time. Now as you could see in the graph that this is a speed time graph. In no way that you would be able to use the formula, which is speed is equal to distance over time, and distance is equal to speed times time. You cannot use this because the slope here is not distance. The slope here refers to acceleration. The slope here is y over x. Remember the rise over the run? The slope here is speed over time. And speed over the time is equal to acceleration. That is velocity over the time. So in no way that you would be able to use the formula, which is distance is speed times time. You cannot use that. So instead, you would be able to use the area under the slope. The area here refers to the distance. And since this is a rectangle, therefore the distance here is equal to the length times the width. That would be the formula that you would be using. So the distance here is equal to length times the width. Now our length here is the longer dimension, and this would be our length. So let's measure the length here. So this would be 2, 4, 6, 8. So since this is 21 and this 25, so this would be 20 to 25, so this would be 21, 22, 23, 24. So point A here is at 23.5 meters per second. So you're going to use that value here. That's 23.5 meters per second. And our width is 0.7. That would be 0.7 second. Cancel the second. And the distance here would be equal to 16.45 meters. That's the answer. Okay, so there's a succeeding question. I'm going to solve for the next question. calculate the deceleration of the car after the brakes were applied. So we need to find the deceleration, and deceleration is the negative acceleration. Now on the graph, you would notice that it is moving from 23 meters per second to 0 meter per second. So our deceleration there would be the change of velocity over the change of time. So acceleration is equal to Vf minus the Vi over Tf minus the Ti. And that would be 0 minus 23.5 meters per second divided by the total time. Or no, sorry, final time. So the final time in here, so let's measure this. It is 2, 4, 6, 8. So that would be 4.2, 0.4, 0.6, 0.7. That's 4.7 seconds. So you will write here 4.7 seconds, take away 0.7 seconds. And that would be negative 23.5 meters per second divided by 4 seconds. You cancel that. No, you cannot cancel because this is the denominator and this is also a denominator, so it's expected our answer would be meter per second squared. So that would be negative 5.88 meters per second squared. And since we only have one decimal place, so our answer would be acceleration is negative 5.9 meters per second squared. That would be our answer. Next question is calculate the distance traveled by the car while the brakes were being applied. So the distance here, like what we did a while ago, the distance here refers to the area under B and C. So the area here, since this is a triangle, so that would be 1/2 base times the height. So you're going to use that. That would be distance is equal to 1/2 base times height. So 1/2, and our base here is this 4.7 minus 0.7, so that would be 4 seconds. So that would be 4 seconds times the height, which is 23.5. Okay, then that would give you an answer of 47 meters. So the distance traveled by the car while the brakes are applied is 47 meters. Now describe how the graph would be different if the brakes applied more force to the car. And the tendency is if the driver applies more force on the brake, then this will be steeper. Okay, so it will be able to stop at a lesser time. So the slope here, the slope on the graph will become more steeper. Okay, so the slope on the graph will become more steeper. So that's the answer for this question, and I hope you learned something and you would be able to utilize this in preparation for your examination. Thanks for watching.